Assalamualaikum and good morning to everyone. Today I'm feeling very honored to be a part of the International Conference on Education, Humanities and Technology Research. Without further ado, let me introduce myself. I'm Dr. Firdaus from University of Science Malaysia, and the title of my presentation is Anionic Dye Removal by Durian Peel-Based Activated Carbon, Isotherm Kinetic and Thermodynamic Study. My presentation comprised of 5 parts, which is introduction, followed by objective, research methodology, result and discussion, and lastly conclusion. Rimazole Brilliant Blue R or RBBR is an ionic dye. An ionic dye is dye that dissolve in water to produce negative ion. These negative ions are attracted to the positive sides of the water molecule. Therefore, it is harder to remove an ionic dye as compared to the non-ionic dye. Figure 1 shows the discharge of the anionic wastewater from the industry, and Figure 2 shows the chemical structure of the RBBR dye. Due to the improper treatment of wastewater, dyes make their way to enter the environment, and once they enter the environment, they can cause harmful effects toward human and animal. Upon contact with human, RBBR dye can cause severe effects such as renal complication, dermatological diseases, and reproductive system disorder. One of the most promising and effective methods to treat anionic dye from the wastewater is absorption process by using activated carbon. However, the commercially available activated carbon are usually derived from lignite, bituminous coal, and petroleum coke. These precursors are non-renewables and relatively expensive. To cope with this limitation, this study has chosen durian peel to be converted into activated carbon. Durian peel has been chosen because they are available abundantly, cheap, having good physical characteristics, and by converting durian peel into activated carbon, it can solve the durian peel disposal problem. There are 3 objectives in this study. The first one is to convert the durian peel into activated carbon via physicochemical activation by using sodium carbonate and carbon dioxide for RBBR removal. Secondly, to investigate the effect of the RBBR initial concentration and solution temperature on RBBR removal. The last objective is to evaluate the isotherm, kinetic, and thermodynamic study on RBBR DPAC absorption system. Figure 3 shows the research methodology employed in this study. Firstly, durian peel is being prepared and carbonized at temperature of 700 degrees Celsius for 2 hours under the flow of nitrogen gas. Then the resulted char is being activated by chemical activation by using sodium carbonate at impregnation ratio of 1.87. Then, the impregnated char is being activated by using physical activation at temperature of 740 degrees Celsius for 2.47 hours under the flow of the carbon dioxide gas. Then, the resulted activated carbon is being used for the batch studies, isotherm study, kinetic study, and thermodynamic study. Table 1 shows the surface area and pore characteristic of the sample. We can see that the BET surface area of DP char is 287.64 meters squared per gram. This value increased significantly in DPAC, which is 570.41 meters squared per gram. The total pore volume also increased from 0.369 centimeter cubic per gram in DP char into 0.434 centimeter cubic per gram in DPAC. This increment is a proof of the effectiveness of the physicochemical activation employed in this study. During the chemical activation, the sodium molecule penetrates deep into the char to create pores. And then during the physical activation, the CO2 molecules bombarded the surface of the char to create more pores. As the result, the BET surface area and total pore volume increase. The average pore diameter found for DPAC is 3.48 nanometer. This value lies in the region of mesopores type of pore. Therefore, DPAC is suitable to be used to absorb RBBR in an aqueous solution. Figure 4 shows the SEM images for DP and DPAC. In DP, we can see that the existence of pores is very minimal, but after carbonization and physicochemical activation, we can see that numerous pores exist on the surface of the DPAC. Next is result and discussion for batch studies. Figure 5 shows the RBBR absorption uptakes versus time at various RBBR initial concentration. From the plot, we can see that RBBR uptakes increased with time until a constant value was reached. This constant value indicates a saturation point where no RBBR molecules can be removed anymore. It was also found that lower initial concentration reach equilibrium point faster compared to the higher initial concentration. This is because at lower initial concentration, the ratio of the RBBR molecules to the available surface area is low as compared to the higher initial concentration. The next parameter being investigated in the BEST studies is the effect of the solution temperature. Figure 6 shows the effect of the RBBR solution temperature on RBBR absorption uptake. From the graph, we can see that RBBR uptakes decrease with the decreasing of the RBBR solution temperature. This is because at higher solution temperature, RBBR molecule gain more energy to escape from the DPAC surface. For isotherm studies, 3 models were studied, which is Lamware, Freundlich, and Temkin. These plots are given in Figure 7, Figure 8, and Figure 9 respectively. To determine which model describes the data the best, the value correlation coefficient is to be compared. And from the comparison, Freundlich model describes data the best due to the highest R-squared value it gave, which is 0.9850. This indicates that the absorption of RBBR occurred on heterogeneous surface of DPAC and multilayer absorption occurred. The Lamware monolayer absorption capacity was found to be 125 mg per gram. For kinetic studies, 2 kinetic models were used, which is pseudo first order and pseudo second order. And from the comparison of the correlation coefficient R-squared, it was found that pseudo second order described the kinetic data the best. It was also found that the rate constant for pseudo first order and pseudo second order decreasing with the increasing of the initial concentration. This is because at higher concentration, the ratio of the RBBR molecules to the available surface area is high. Therefore, the absorption process becomes slower and the rate constant decreases. Last but not least is the thermodynamic studies, and table 4 shows the thermodynamic parameters. The value for change of enthalpy is negative, and this indicates exothermic in nature, which explains the lower RBBR uptakes at higher temperature. The negative value of change of entropy indicates that there is a decrease in randomness at solid-liquid interface. The value for activation energy is 39.83 kJ per mole. Since this value is below than 40 kJ per mole, therefore it confirms that the absorption process is governed by physis option. The value for Gibbs free energy is negative, therefore indicates that the absorption process is feasible and spontaneous in nature. The conclusion for these studies are as follows. Firstly, durian peel was successfully converted to DPAC via physico-chemical activation using sodium carbonate and carbon dioxide, and DPAC was found to have relatively moderate BET surface area of 570.41 m² per gram and Lamware monolayer absorption capacity of 125 mg per gram in removing RBBR dye. Secondly, BEST studies revealed that lower RBBR initial concentration took shorter time to attain equilibrium as compared to the higher RBBR initial concentration. Thirdly, isotherm and kinetic studies revealed that the absorption of RBBR dye onto DPAC were best described by Freundlich and pseudo second order respectively. Lastly, thermodynamic study revealed that the absorption of RBBR onto DPAC was exothermic in nature, feasible, spontaneous, and governed by physis option. I would like to take this opportunity to record an appreciation note to University of Science Malaysia and Ministry of Higher Education via MyBrain 15 due to their support to this study in the form of grant, scholarship, and facilities. That is all. Thank you.